Hey everyone, class is not over. Oh my gosh, what we got going on here? Class is over. What? Class is over? No, we got the lamp bouncing around. What is going on? Class is over and the lamp is bouncing. Oh my gosh. We got to cut that out. We got to cut it out. Got boop. No more lamp. Probably been there for a while. Who's in the chat? We'll do some coding here. We'll see how long we go. Maybe 30 minutes, maybe an hour. You never know. If you're in the chat, feel free to say hi. Let's start talking a little bit about this week's coding, what people are doing. Hey, Meath, good to see you. Which questions do you have, or what are you wondering about? We got Mewbot here. Let's throw out Meath as first. Get that 1,000 points. Keep earning those points. We're going to see who the top winner is this semester. I can see who the top winner is. I don't know if I can say. Let me see who is the current top point getter. It might be a 201 student. A lot of 201 students are coming to regular office hours. Good to see you here. Sam, Shreya, good to see you here. What do people want to work on? You tell me. It's Maris, your guys' time. This section is dedicated completely to coding in R. So you could ask a 201 question, but we'd have to do it in R. This is our weekly coding in R. Who's the winner right now? I'm the winner. Ooh, I could tell you who the winner is. You could ask if you're the winner, maybe. Some close calls. Really, some people up there with the points. So great job. It's really cool seeing the top. Is there a relationship between discrepancy and p-value? Good question. Let's start that off right here with some 320 talk. This is 238. BS 320, discrepancies and p-values. Let's go take a look at that right here. So the question is there a relationship between discrepancies and p-values? Does discrepancy increase when p-value is lower? I think you know the answers. So let's pull up a data set right here. Like the data survey 09. Okay. So let's take a look here. The associate function is going to allow us to look at the association between variables. I'm going to cheat and use the attach function. When you use the attach function, you can then access the vectors by typing them in. See how XO2, probably because I've already attached it. Detach. Detach? No, I thought it was detach. What? Invalid. Oh, it probably needs to be in quotes. Well, I must have already attached it a while ago. So here, watch this. We'll reset our... Well, this... same question. All right. So now it's attached those right there. Oh, I had a different data set with the same variable names. So this is called what's called masking right here. Masking, and so Shreya knows about this, right? When you have two things like select right here, select is in dplyr, but select, I think, is also in the mass package. So when you have... Oh, we didn't pull the right one. Select can be in two different things. So there's select in the mass package, but only one of them can be used. So there's a select inside of here. This is calling it from the package. So you can tell which one is being used. So right now, dplyr is the select that I have. So it's masking the one from, and that's what we call masking. Like, think about like you're wearing a mask over something. So when it said that these are masked, it's because there was already that thing existing. So it said like, nope, it's now this. So I did have an XO2. So when I loaded in or I attached that, it then masked those. So now when I call it, it's going to call it from this data frame. So if I go over here and use the survey 11 again, which we already had loaded up, it's going to, we don't have survey 11 loaded up. Survey 10? No, survey 11 has the numbers in it. Now when I attach survey 11, it's probably going to say it's masking again. And it's masking things that are already there, and it's just saying a bunch of things have been masked. So masking means two things have been trying to fight for each other for what it is. And so now I've just overwritten what it was calling there. Now, the reason I like to use attach is because when I type the name of the variable, I don't have to worry about the syntax so much. When I look at the relationship between like people's gender and whether they were born in Tennessee, so born in Tennessee is going to be my first one. Do you think somebody's gender is associated, just a yes or no? Do you think someone's gender is associated with them being born in Tennessee? Do you think somebody's gender is associated with them being born in Tennessee? What do you think? I don't think so. I mean, maybe we'll find out it is, but I don't think so. Great job, Sam and Meath. Good work right there. And Trey, excellent work too. So the discrepancies between males and females is probably going to be very what? The discrepancies, which is the differences in the conditional distributions is probably going to be very what between males and females. The discrepancy is probably going to be pretty what? Small or large is what I'm looking for. Because I don't think there's a relationship. So if there is a discrepancy, it's probably going to be pretty what? So the discrepancy between males and females is probably going to be pretty what? The discrepancy is probably going to be very small, right? And a small discrepancy, like a little discrepancy like this, sounds like it could or could not be by random chance. Now, we'll get the answer to the probability of by random chance, but a small discrepancy means it's probably likely by random chance that we saw this, or unlikely by random chance, if it's a very small discrepancy between the groups. Would that sound like it's a likely by random chance difference or an unlikely by random chance difference? Because we assume that there really is no difference until we have evidence of it. So if there's a small discrepancy, that would sound like something that is what by random chance? A small discrepancy, would that sound likely or unlikely by random chance? Like little differences, do those sound likely like they're random chance or unlikely by random chance? Likely. So we've just theoretically thought about this. We expect the discrepancy to be close to 0, and we expect the p-value to be higher. So here we are. The discrepancy is kind of closest to 0. P-value is a little bit lower than I thought, but is this statistically significant? Simply yes or no in the chat. Is that statistically significant? We're throwing another 1,000 points just for the people being here. Throwing big points. If you're here, you get those points. Is that statistically significant? Just looking at this right here, is that statistically significant? Is it? Not statistically significant. And that automatically means it's not practically. Now, we could interpret this, and we could say, given someone is male, there was a 63.6% probability they grew up in the U.S. Given there was someone is female, there was a 58.9. That's, oh, born in Tennessee. I was like, that's low for grew up in the, like, I mean, we're a Tennessee school, so that's, I'd be like, whoa, only 63.6% appeal, because there's a grew up in U.S. variable too. But these are the people born in Tennessee, which were a Tennessee school, so hey, it's what we kind of expected to be higher. But what about, I think there's a grew up in the U.S. variable. Is there not? Do people see, maybe it's in the other data set. How about this? Let's see, does born in Tennessee explain if Tennessee is your first choice? What do you think? People born in Tennessee would be more or less likely to have Tennessee be their first choice. What do you think? You could go theoretically either which way on this, I think. So now we're seeing if you're born in Tennessee, does that explain if Tennessee is your first choice? I would think you might be more likely, right? Does it make sense? Like if you're born in Tennessee, you might be like, hey, I want to go to UT. Go Vols. So I'd say probably a greater proportion of people born in Tennessee wanted to go to Tennessee first choice. And born in Tennessee, yes, a little bit higher. And look, the discrepancy here between these is a little wider compared to the last one. Do you see the discrepancy is a little bit wider? And you can see the numeric value of the discrepancy that compared to the last one, which this is the numeric computation of the sum of the cell chi-squareds, which that's no longer the right value on the screen. The right value for it is here. See, it's about at 1. It's a larger discrepancy. Yep. And that's the calculation of it right there. It's right above 8, and that's our observed discrepancy. Now, these are random chance discrepancies right here. If I remove the seed, it'll randomly do the p-value each time. So now the p-value is random because the random discrepancies are random. I would suggest using a set seed to control the randomness. As long as you pick the same seed, it's going to give you the same results. So when I run this code, it's going to give the same result every time. The discrepancy is still in the same spot. But notice, like you said, Meath, the discrepancy is water, and thus the p-value is water. Here, the discrepancy is water, so the p-value is water. Larger discrepancy means water p-value, and you're totally right there. Because larger discrepancies are less likely by random chance. Less likely by random chance means this. And you are totally right about the theory that when a discrepancy is larger, that means it's further over on the curve, which then there's less permutations that are beyond it. Lower p-value, exactly. So you can't exactly, what we're actually doing here theoretically, I think Mubot can bring us to it. We're actually simulating, this is a simulated chi-squared test. So Mubot is bringing us right here to the actual applet where we could calculate it, but we're actually simulating the results, which is better because there's no assumptions because we're using randomness to do the results. Since this is a 2x2 test, it's a chi-squared statistic or a chi-squared 1 degree of freedom. Does our curve down here, let me do this. Permutations of Does that curve on the screen look anything like or similar to the curve right there? Look at how that curve goes to about 9-ish. Does that curve on the screen look anything like this over here? So right skew over there. And let's take our chi-squared value of 8.122 right here. Drop it over here and do above. And it says 0.04. So this is what it's actually finding for us. See how that's 0.04? So we're actually simulating the chi-squared distribution. And depending on this right here, like if we did something like class, like XO3 class, wait, oh, there's XO5 class. See, I've got a bunch of different things. We are simulating a different chi-squared. This chi-squared is a chi-squared with 4 degrees of freedom. No, 3, excuse me. So we would take the discrepancy here, and we could enter in 3 degrees of freedom chi-squared of this. And if you look at the shape of it, just look at the shape of this right here, and look at the shape right here. This is a simulated chi-squared. We get an estimated p-value of about 0.32, and the chi-squared classical version gets a 0.32 also. Now, we could get a better estimate and would probably start to converge towards that if we did something like 10,000 random procedures. And so it's simulating it. And it's just going to simulate random results and get an estimate of the p-value, and we get 0.3277. And the reason we do this is there's no assumptions. The chi-squared has assumptions about your data. We don't have to use any assumptions. It's literally it's literally looking at what would happen via randomness, and it's actually converging towards the answers that classical statistics would find. So the permutation procedure randomly looks at your data, as in we create random permutations of our data, and I'll show what that looks like. If I have right here your test grade, Meath and Mason, congratulations, you both got hundreds. That's a joke. I'm just putting in fake test grades. I hope you get hundreds. Don't want anyone to think I'm actually telling test grades right now. So right here, I have a vector of test grades, and I want you to look at this right here. The first 2 people studied, and so did the third person. Everyone else did not study. How many extras are there? 1, 2, 3, 4, 5, 6. So if you just look at this right here, if you look at this, does it look like there's an association between studying and how well you did on the test? Does it look like it? Just look at the grades of these individuals and these individuals. Does it look like there's an association? What would you say? Here, I'll put a note right here, the permutation procedure. Does it look like there's an association? It does. It definitely does, right? Like, look at the grades of those who studied. So what we can actually do is we can run the associate. I hope it has enough data to do it. Y tilde X. Now, those are not stored to the global environment. It's mad. I think there's not enough data. It's like, I can't do it. I can't run it on that small of a data frame. Associate procedure. Why do you do that? 2 levels to proceed. Oh, it's not a factor. It's not a factor. There we go. It was a string, so it was mad. Still a mad? Wait, it's Y. We need to call this X and Y. That's Y. That's X. There we go. Now we've done it. Okay. So that little tiny function right there, because those who studied had a higher grade on average, right? So tell me about the average grade of those who studied. Tell me about the average grade of those who studied. It's in the output now, and this is next class. Tell me about the average grade of the people who studied. What was the average grade of people who studied? You can look at the output to cheat. What was the average grade of the people who studied? So look at the output to cheat over there. Not cheat, but the people who studied had an average of not quite a 94. Maybe it was previously. Now the average for those who studied was a 90. That's the median. Up. That's the median down there. Good answer, Meath. That's the median. So you get the median and you get the averages. So we might want to use the medians. I don't know. It's not normal. We'll get into when we would use the medians versus the means. Great job, Sherry, right there too. The mean of people who study is a 91.5, and the mean of people who didn't study is a 51.83. Is this difference statistically significant between these two groups? Now we have a small sample size, but don't worry. No worries, Meath. Is this difference statistically significant? Yes or no? What do you think? So use the output right there to help you out. Is that difference statistically significant? So statistically significant means p-value less than 0.05. It is. It most definitely is. Wait, it's the p-value's low, and the discrepancy once again is rather what? The p-value is low, and you can see the discrepancy. Oh, it made the output weird. I don't know if we did a set seeds, we're going to get different results. The p-value is low, and the discrepancy is rather what? It's a big discrepancy. So this is our discrepancy for the averages, and this p-value might be estimated to be 0 because it looks like we didn't get one as large as, we probably didn't, or the p-value is still estimated to be 0.002. So there was one of the random discrepancies that was as large or larger. So when you think about this right here, well, what's a permutation? A permutation means I take and I sample from the y vector, and I take your grades and I completely what-ize them. So this is a permutated y. I take your y grade, I take your grade and I what-ize it. So now your grade has been what-ized. And you can see, if we go to make a data frame of this, your grade is completely what? Random. So if we saw any differences here, those differences would be due to what? If we saw any differences here, the differences in this data that we're looking at would actually be due to what? Because we just randomized it. So if we saw any differences in the data, they would actually be due to what? Look at all those people. Whoa. Oh, wow. It randomized it so that almost all the lowest grades were people who failed. Wow. But we could just repermutate it. There's the permutation. There's the right. And did just do it again? No way. Repermutate that. Oh, I didn't save it. Permutate it. And remake it. There we go. Wow, both of them were pretty low. So these are just random permutations. So everything you see over here in the histogram is a random permutation. A lot of times, permutations have what discrepancies? Because they're just random. A lot of times, the permutations and the discrepancies are what? So think about where I'm pointing out on the graphic. A lot of times, permutations and a discrepancy are rather what-ish, because they are just random. Look at what value I'm pointing at, and think about how you describe that value. A lot of times, a permutation, which is just random, will have a discrepancy that's rather what? Or close to what? Because it's just randomly putting the data together. Close to 0, very small. So a lot of times the discrepancies by random chance are rather small. Would you like that, Meath, if you studied really hard and I just tossed your tests up in the air and I said, pick the test closest to you, it's your test? You don't get to see what the test is. You just pick up the test and it's your grade. Because that would destroy any association between your studying and the test grade. So any relationship we see in a permutation is due to random chance. So that's why we look at our result and we see what percent of the random results are as extreme as our result to tell us how likely our result is by random chance. Does that make sense, Meath? As we say, like, our result seems very unlikely by random chance. Like, this is what is happening by random chance if we just randomize the data. This is what we saw in our result. Our result is far away from those, so our result is unlikely by random chance. Makes sense? Awesome. Yeah, once it's like, okay, that's what the p-value is. And if you look at this right here, our result is way over here, which seems unlikely by random chance. Let's increase the permutations. So this is a great question. I love doing something like this. What is the p-value here? Well, I ran 10 random mixing ups of the data. We landed here. So what is the math to find the p-value? You can see the p-value. So I ran 10 random permutations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 0.1 because there's only one random permutation. So if you're shading, that's beyond our result, at or beyond. So if you're shading it and drawing the p-value as a shaded region, you would just go here and shade this because it's the results at or beyond your result. This is our result right here, our result. There we go, double T, our result, our result. And so usually we don't do 10 permutations, we do something like 800. Now be careful. How could you figure this out? This is a very tough test question, Meath. How could you figure out how many numeric permutations, like the number of permutations that are at or beyond ours. So I think you understand it really well if you can figure out using the p-value, that is the percent of permutations that are at or beyond, but how many of the random permutated results were at or beyond. So you really understand this output really well if you're like, oh, well, then we could figure out how many of the 800 if what. I'm giving some hints right there. And Meath, great job working right here, understanding this output. This is a very high-level understanding. We're throwing you 500 points. How could you figure out how many of the permutations were at or beyond? Because we did 800 random permutations, 28.375% of them, which looks like this difference is due to random chance. So how could we figure out how many of those permutations? Because we know the percent of the permutations. We know how many permutations. So basically, we're trying to see what the computer did to find this. So how many permutations are at or beyond that red line? How could we figure that out? What could we do? So we know it's 28.375% of this curve. We know we did 800 permutations. Well, 1 minus p-value would be the percent on this side. That's the complement. That would be the ones that are below our result. Close, Meath. Good guess. That would be the ones that are as at or less likely than ours, or less likely by random chance. Or more likely. Wait, I can't think. I can't do a reverse p-value. Results that are as extreme or more extreme than our result happening by random chance. Results that are less extreme than our result happening by random chance. That would be 1 minus p-value. I've never had to interpret that before. Results that are less extreme than our result happening by random chance. Oh, we wouldn't do that though. What we could do is we could multiply this. Because think, that means there's 227 random permutations that are more extreme. Does that make sense right there? Maybe that this is a very deep level of understanding of this sort of output to understand that the computer calculated 227 results. The height of the bin tells you how many results are in the bin. So there's more results in this bin than there is over here. There's very results that are as extreme, but there were a few that were discrepancies were this high by random chance. But the results that are as of more extreme than our result are 227 results out of the 800 total. I found that by knowing that there's 28.375% of results that are as extreme or more extreme than ours, did by the 800 to find out how many there were to begin with. And that's definitely a tough question. Like if I put it on the test, you have to back work it to find it and understand the output inside and out. What do you think in Meath? What do you, so on the right side of the line there, yep, there's two, if we counted everything right there, there'd be 227 observed results. Just like, think about how when we're doing it here, we can literally count it because there you can see it's 0. Let me turn off the seed. Here you can tell the p-value is 0.25. Yes, exactly. Yep. And then does that make sense? Because here you can tell it's 1, meaning 25, and here you can see 75. It's easier to see with a smaller amount. And that's why if you take this, if you go 4 times this, whoops, where's it? 4 times this, you get 1, and that means there's 3 over here. But the bars start to stack up as you get more of them. So you can probably count this one. 1, 2, 3, 4, 5. Remember the height of the bar? 6, 7, 8, 9, 10, 11. So it looks to be 11 out of 40, and 11 out of 40 is that right there. You have to be very. It's harder to count when you do this because that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then there'd be 29 over here on this side if you had to count 1, 2, 3, 4, 5. Yeah. Does that make sense, Meath? It's easier to say we did 40 permutations, and this is the amount that was more extreme, and then that's how we're getting right there. This is a very in-depth understanding. It's just that when you go towards something like 400, it's going to be very hard to count like 1, 2. It's going to be very hard to count in this. Yeah. So if you understand at that level, that's a very high understanding, just bringing it to like, okay, this is the p-value, the percent of permutations that are as or more extreme than our discrepancy. And our discrepancy right here, you can see visually is about 3.7 or something, or it's 3.4, because it's right there. Yeah, because 2, 2.5, 3, 3.5, and it's right below 3.5. So it's right there, just on the number line. That is the visual mark where that line is at. And then the p-value is the amount of discrepancies that are at or more extreme. Just so I can circle this and show it to you. What did I click? This output down here on the bottom, it's very important we understand that this value right here is the amount of discrepancies that are at or more extreme. I think Meath gets that really well. And then this value right here is the discrepancy value, which is where the line is marked right there. So the discrepancy is the actual observed discrepancy, which is a way to quantify the differences we are seeing up here. Let me kind of highlight that. So it's a quantification, a way to kind of assign a math value to these differences between these blocks right here, which they looked small. And yeah, they are small because the discrepancy right here is trying to quantify those differences, which those differences appear to be small. Where if we do something with like, let's find a variable. We're doing the 09 data set. So if we did something like trying to find born in Tennessee, what would be a good difference for born in Tennessee? Be cool if we did like attractiveness. 474 lab, run that. Yeah, let's take a look at it here next, Trey. You got it. Let's look at, what should we do? Computer. Let's see if there's a difference with computers. Computers and Greek life. I think there is. I think Greek life might be more likely to use max. And oops, wait, I have GPA. Whoops, because we got 2 data sets with the X07 stuff. Nope, differences are likely by random chance. Greek life and sure, yeah, we'll do awesome. Greek life and do you read the beacon? No. Darn, 2 data sets with the same thing. That's why differences by random chance. Last try out here. See, we keep getting differences by random chance. One more try. Greek life and there was, I'm not finding anything. No. Parents graduated from college. I bet that'll be it. X36. Woo, we finally found it. It is a large enough discrepancy right here. Do the stops messages need to be inside the loop? Yes, they can be. You can put them outside. Just depends on how you write it. They don't have to be. You just have to get your messages in there. You will need the break and yeah, stop needs to be inside the loop. You have to put a stop inside the loop because it has to stop the loop. So the stop, yes. Messages could be printed afterwards or at the start. Messages could be at the start or at the end, afterwards after the code runs. The stop has to be inside the loop because it has to break the loop. So make sure to use a break on the loop right there. So good question, Sam. But yes, you have to stop a loop with a break. But then also the messages could be outside as long as you get the messages there. Good questions. Let's go over here. Let's do the, what is it? The random uniform. Oh yeah, explains random uniform. Yeah. Let's talk about randomness functions right here. 474. I was going to play a little music here. So BAS 474. Random uniform. Random norm. Random exponential. Okay. And let's talk about these functions a little bit here. Good stuff to know. Maybe we'll do some loops too. Here we go. Okay, so when we're using some randomness functions right here, it can really help to draw values. Like let's say I were to tell you, and this is a good 201 320 review, I were to tell you test grades, you're welcome, Meet, excellent work right there. I were to tell you test grades on a test are normally distributed with a mean of 80 and a standard deviation of 10. Let's go standard deviation of 7. Bringing the curve in a little bit here. Well, could you draw that curve for me? Can anyone draw the curve? Test grades are normally distributed. If you want, you can go to David M. Lane, especially if you're in 201, is a great way to do it. I'm going to draw the curve out here a little bit differently and simulate it. I'll show you how to simulate the curve. So the David M. Lane curve, Brian said test grades are normally distributed with a mean of 80, standard deviation of 7, and we draw the curve. But how could we do this inside of R via simulated normal distribution? Well, we use randomness. Randomness allows us to do simulation, and we type rnorm. This means we're simulating from the random distribution. Now, we need to choose how many values are we simulating. We are creating n random values. So I'm going to simulate 1,000. Then we enter in the second argument, which is the mean, and the next is the standard deviation. But I'm going to pause here, and those arguments already have what? The second and third arguments already have, starts with a D, covered it in class, already have what values? Because they have an equals. So it would be that those already have what values. And then think about why it's set up that way. Defaults, great job, Shreya, right there. So it's set up to do z-scores, right? Because the mean of 0, standard deviation 1, z-scores. So great work, Shreya. We're throwing some 500 points in the chat right here. And then let's simulate the normal right here. Great job. So we're going to go right here and do 1,000 values. And we can just type the next value. A mean of 80, we said, and a standard deviation of 7. There's the values. To turn it into a histogram, we can go right here and go hist. And that'll turn it into a histogram, and it looks very similar to our David M. Lane graphic. Here's the David M. Lane graphic for us, and here is our graphic over here on the side. And you can notice they both go a little bit past 60 and up to 101. Now, David M. Lane puts the z-score on it for you right there, where ours is just doing it by what it believes it to be. But here's the thing. I really like library ggpubr. It has in it gghistogram, which I'm going to cheat and remember how to do my cool histograms here. So a lot of times it wants you to have it inside of a data frame. Always drives me crazy. So it's got right here the data frame. We need to do the data. We're just doing the X. So here we go. Let's store this in a data frame and call it data.frame. There we go, data frame. Open it up. Call it X equals this. That's just the name of the variable we're doing. And it's mad. Oh, because I called it hist. We don't want the hist on there right now. There it is right there. And there's our data frame, which just has an X variable in it. So now if we go back and look at our instructions right here, it's using X equals weight. So when we grab this right here, we just need to drop it in. And we're going to make it look nice and pretty right here. First argument is the data frame, which I called data frame. Second one is the name of our X variable. The next is our fill, which of course is going to be UT orange, which is hashtag FF8200. We could add the mean to it and a rug to it. And just in moments right here, we've got a much better looking histogram. So now we're able to actually see it, and we can simulate this histogram pretty easily. Just right here, you notice it gives different random histograms just like that. Lots of different things we can do. And of course, as Brian always likes, if we store it into an object right here, I'll store it in the object P right here. And it's mad about the things. We can go to ggplotly, which I don't have loaded up. So that means we need to go to library, ggplotly, and nope, plotly, sorry. Oh my gosh. And now we go ggplotly, and we make our graphic. Oh, there we go, interactive. Woo! There it is. There's the mean right there. You can actually do different things. You can add the mean, you can add the median, especially what if our data was skewed? So what if our data was skewed here, Shreya, and we just wanted to do GG or labs. If our data is skewed, oh, because we didn't run it. If our data is skewed, then what should we use instead, Shreya? We shouldn't use the mean, we should use the what to talk about our data. If our data is skewed, we shouldn't use the mean, we should use the what. The median, yep. If the data is skewed, we should use the median. So what if we had exponential data? Now, exponential doesn't take those arguments. I should look over the arguments it takes. Random exponential takes the rate. And I don't really do the rate. The mean, 1 divided by rate. I haven't done that much. So I haven't worked with those arguments, but now we have a different data set, and take a look. It's skewed. So this samples from the exponential data set, and we'll change the rate here and see what it does. So this is just a different rate right here of different random data. Here we'll do a rate of 30. And it looks, you see, it's the number line's smaller. So let's put a rate of 0.1. You see it's going out towards 40. So this is over a longer scale right here because it's sampling from the exponential distribution, random numbers, 1,000, and it's using this as the parameter which controls it. So this was a different rate right here. And we could even do something like paste. We could say exponential with rate. And then we could put here rate equals 1. Store the rate as this over here. And there it's got it right there. Rate not, oh, we didn't follow the rate. And now we run this and we put rate right here. And I want to show you what we're going to do with this because we're going to wrap it into this week's assignment. And take a look. If I change the rate right here Does that make sense? It's actively putting it in there. Now, let's say, Shreya, is this seeming a little bit complicated, Shreya? Is this seeming like a good bit of work? Like, I mean, not too complicated, but is it like, it's a little bit of work, right? We could take all this work we've done right here and turn it into a what? Not crazy, right? So we simulated a few different distributions right here. Watch this. We could take our normal curve we made, and the normal curve right here, we could say normal curve, paste normal curve, and we'll just do the random normal. And there it is right there. We'll just take random normal curve. There we go. So right here, well, we could loop it. We could loop it to a bunch of times. Or with what we have right here, let's take our code and put it inside of a function. So we're going to have all this right here. And let's take all of it and go fun and think about this. Now, what is the most important thing for somebody to enter in our code? What is the most important thing maybe for someone to enter? Oh, no worries. We could make it into a dashboard. I could do that here in a moment if you want. I could put it in a dashboard and have someone generate this with a dashboard. What could someone enter into our thing right here? What could someone enter in that we could give them the options to control? We'd say, make histogram. Well, so like, what could they change right here about this? We could return P. Well, we could worry about what they enter in. We could worry that they enter in bad things like characters and stuff. But what could they control in our function? The rate. They could change the rate. Yeah, let's do that right here. Let's go rate, and there we go. So now we could do the rate. How about we allow them to enter in sample size? And so now they can enter in the sample size. And where's sample size down here? Where is it? Wait, do not generate those random normals. Oh, wait, here's right here. X, there it is, sample size. All right, so now we have the sample size they get to enter in, and they enter in the rate. But we have two options. So how about if we call this G2 for graphic 2, and we call this G1. Now, you notice we're returning P, but let's write an if statement right here. And let's say normal equals true. Does that make sense? So if normal equals, or if normal, then do what? So how can I make it so that they'll get that right there? So if normal, run what? Can you solve this right here? I want to make it so if it's normal, they'll get this, else they'll get something else. They're going to get object P. So what should I do right here? If normal what? If normal what? So yeah, think about what we'll do right here. If they say that they want the normal, then we'll do what? Well, pretty much. Well, kind of. Well, they're going to get P. Remember that. They're going to get object P. So think about what we're going to do with P and G2 and G1. So if normal, then what? Because we've got G1 and G2, but we're going to return them P. So if normal, then they'll do what? Yeah, Kyle, let me know which thing you're wondering about. Feel free to drop a word. Doing some functions and loops. So if it's normal, I'll give you a hint. Ready? There's a hint. Which I think, so if it's normal, well, we could do, actually, Shreya, that's right. We could just do that. Well, Shreya, oh, there you go. If normal, return G2. There you go. Why not do that? There you go. I was going to store into the object P. If not, return G1. There you go. That works. That should work. Let's try it. So make histogram. And they enter in a sample size of 50. So we put in a rate. Put in a rate here. Put in a rate of 2 by default. They don't actually need the rate, but they'll put it in still. And then normal equals true. And there you go. It's doing a bunch of, we could suppress warnings. I wonder if suppress warnings work on this. Suppress warnings G2. Don't like those warnings. No! I thought it would do. Yeah, so we can change these now and change it away from a normal. Normal false right there. So now it gives the exponential and it does the rate. It's doing a bunch of warnings right there. Probably need to do suppress warnings here. And then we'll switch. Let me know which thing you're working on, Kyle, right there. And we'll take a look. There we go. Let's try that. Hey, we did it. We suppressed the warnings. We like that. And in truth, I would probably move my rate argument over to here. And then we can just do make histogram right here. And there you go. There's a normal histogram. I can't figure out how the skeleton that I insert the for loop function, the first one right there, it looks like the for loop. Did you say question 2? Question 2 is the, yeah, homework 2. Yep. So you're working on the for loop and trying to get, we'll take that here in a moment. Does that make sense, Shreya? So this goes towards your next assignment right here, or just trying to understand how to build functions. But it looks like a lot, but remember we just did it in steps. So we built this right here, and you could throw this into a Shiny app pretty easily from here. It's just gonna have to render your histogram. You'd put the input windows instead of it being a function. So it just depends on how you want to use it. Good questions, Kyle. Let's start that up here in just a second. Here we go. Okay, so we got some for loops here. So it's yeah, well, throw some Shiny in something. Sure, maybe, I don't know. It's good practice. We teach different skills in each course. BS 474, assignment 2, for loops. Let's talk about some for loops here. Let's do it. So when it comes to writing the skeleton of a for loop, how do we write? Oh, you're doing fine, Trey. You got this. How do we start by writing a for loop? Like, we start by writing the what of a for loop. You know him, you love him, he's here. We start by writing a what in our for loops. What do we start by writing? We have to think about how this works. We write that skeleton right there. We write our skeleton. So we have to figure out how our skeleton is going to work. So if you're writing a skeleton in a for loop, if you're doing something like adding interest to your account, you'd have to probably know what. If you're doing something like adding interest to an account, you'd have to know what. So if you're adding interest to an account, you'd have to know what. Say, well, how much money am I going to have? What do we need to know? We need variables, right? We need some things input, right? So what should be some things we need? We need the interest. So what's the interest rate right here? What is my interest rate? It's 2%. Especially if we're going right here, we could go over monthly interest. Monthly interest equals the rate of our interest divided by 12. So there's my monthly interest. What's up, Luciana? Good to see you here. Car payment. The second one right there with the car payment, we know how much we're paying off. Oh, no worries, Kyle. No worries at all. And we need to know investment. So we need to know our investment. We invest $1,000. So we invest $1,000. We're going to make that much interest on it. And then we could see how much we have after the first month. So we could look at our investment at time 1, which is before we go past a month. So how would I know, or how could I pull up my investment at time 1? Now I'm asking in a specific way. Be very careful on how you write this. How can I pull up my investment at time 1? How can I, and go the long way, and you'll see why we're going the long way here. Great job, Kyle, right there. Investment at time 1, right? If I could spell. I can't spell. Investment at time 1. That shows my investment at time 1. Now, why is nothing showing up there? Why is nothing showing up there? Why is nothing showing up there? Haven't calculated, Luciana. Great answer. We haven't calculated. We don't know what it is. So how about we go ahead and calculate that? So if we wanted to calculate that right here, what would we write? What would we write to calculate that? What would we write to calculate that? Let's just calculate that. What would we write to calculate that? Well, so we could try that. Let's give that a shot. Good answers, Kyle, right here. 500 points, Kyle. We can try that. We could try that, but let's see. So what does this do right here? Well, the investment is just going to be, and that's close. You're getting there. That's just going to add $1 to our investment. But well, that we should have our initial investment plus what? A certain amount of what? We should have our initial investment plus a certain amount of what? So what would it be? We would have our initial investment plus the what? How could we define it? So, well, this isn't a payment though. We're not making any payments. We're just putting money in the bank. So but there's no payment. You might be doing a different problem. You might be doing like number 2. We just have this is just put your money in the bank, get some money back. So we're just gonna have our initial investment, and then we have our monthly interest, and then we take what we had, edit to what we had, do the interest, and there we go. There we go. Does that make sense right there? And now take a look. I'm going to stop working the problem here in a second, but look. Because notice what we have right here. It should be okay, cool. Do you see it? Is it working? Well, look, yeah, we'll talk a little number 2. This is like getting started. It's huge hints. Because what does it look like I'm creating right here? What does it look like I'm creating? Because number 2 is a while loop. I thought you said for loop, so this is a for loop question. What does it look like I'm creating right here? What does it look like I'm creating? By showing it has that format right there. Looks like a skeleton, right? So now I can write, and then I just have to think about how to put that into a for loop. Now, remember, our goal is a lot of times to write out the skeleton. That way it can repeat over and over again. Like we can get a code that we can just repeat, and just takes practice. It's like, okay, how do I write a code that I can then change that will then update every time I run it, and then just change an element in it or something. So the other one right here, now we're talking about a car loan. And now the car loan is going to have an initial amount. What else does a car loan have? What else does a car loan have? It would have the initial amount. It's going to have an interest. And the interest rate here is going to be worse. So now we could do the monthly interest. We'll write that vector. And that's going to be the interest. There we go, there's monthly interest. And then we got to make a payment on it, right? So this goes to one of my theories in life. This is Brian's. Life advice with Brian. Pay off debt as fast as you can. Lost the shadow thing on my voice. But I really think a lot of times with loans and stuff, you end up paying tons of interest. So unless you have a very low rate loan, I mean, pay off those high interest ones fast. Shout outs to Dave Ramsey right there. One of the things I massively agree with him on is like trying to live debt free, trying to pay off as much as you can. Not everyone has that luxury, but I've worked my best to pay off every debt I've ever had quickly. Well, maybe post 25-year-old Brian. Younger Brian was not so investment savvy and not so paying off debt savvy, but it's helped me a lot in life to try to live debt free, and I'm just as happy. I've got the things I want: my wife, my bunnies, and some video games. So it makes me happy. So we're gonna make a payment right here. We're gonna make a very strong payment of $1,200 a month. We're saying we're getting rid of this. This thing's gonna be gone. We got a little flex money right there, trifecta right there. Wife, bunny, video games. That is the triforce of things right there. What did Zelda say when Link couldn't open the door? Triforce. I love that joke still. So now when you think about this, the conditions, when are we going to keep paying off our loan? If we talk about a condition, when are we going to keep paying off our loan? When are we going to keep paying off our loan? While it's what? Just think human talk. And we're gonna keep paying it off until it's until it goes until it's 0, right? Or it's less. Like the last payment we have, we could put some ifs in there. We could do like if the amount we are paying is greater than the loan, then only make this payment till we're done paying, till it's paid off, right? So the way that can be checked right here is we need to check how much we're currently at. So we can check, we could look at a loan amount, we could just call it amount. And so we could look at the amount of the loan, the initial amount. How can I pull up the initial amount of the loan again? So once again, similar question to what we were asking a moment ago. I want to look at the initial amount of the loan. I don't want to look at it on start of period 2. I want to know at start of what the initial amount is. Exactly, Luciano, right there. We're going to go amount, position 1 right there. So before I make my payment, there's probably going to be some what on this loan. Before I make a payment, there's probably going to be some what on this loan. Because I want to know how much it's going to be. Like, we could look at what it's at period 2. Now, if I look at what it's at on period 2 right now, it's not there. There's no data there. But I could assume that at period 2, before I make my payment, like right before I make my payment, the amount on the loan will be what? The amount on the loan would be what right here? Before I make my payment, the amount on the loan would be what? How much would be on the loan? Would it be the same? That'd be amazing. I'll be like, I won't pay back that loan. They say, what? I'll say, oh, I'll pay back in 20 years. They say, what? I say, it's not moving. I say, money will be a lot less valuable then. Still worth something, but I'll be, oh my gosh. I'll tell you this much. Houses. Oof. So, why is this not right now? What's wrong? It might be. Well, not with the monthly. Good answer, Kyle, right there. But how are you getting that? The thing is, we can solve a lot of these. This is what I really love, is that coding's a superpower. Because if you talk to someone who knows math, they can solve some questions pretty quickly. But if you talk to someone who's coding, they can solve every question. And they can solve like infinite questions. Yes, someone who knows math, who's like, I'm so good at math, you say, divide all the numbers 1 to 1,000 by 5. And they say, oh, yeah, well, that's just going to be, and you say, oh, too bad, I did it. Oh, I did 1 to 100. But wait, I got to have one more 0 right here. We say, that's easy, because it's that. You say, well, let's divide it by 9.2. Well, there you go. There's every number. So, Kyle, great job right there. But care. Oh, yes, I think you do have it. So we're finding it here mathematically. So you have to think about how we find it. How did you do it in your brain? This right here is calculating the what at the end of it. That is the interest this month, and we're adding it to the initial amount that we were at. So how much did we have? Then how much did we have is used to calculate the interest. So this is just an interest calculation right here. So then, how much would I have in month 3? Very similar to the last problem, right? Oh, but what's going on right here? Dun, dun, dun. What's going on? We're being bad right here. What have we done? What have we done? Just think about what's happening and look at our loan. What have we forgot to do? Just always be thinking about, what does this mean? What does that mean? I'll graph it for you. If you ever want to graph something, we were talking about this earlier today, you can just plot it. And if we plot it, just plot the amount right here. And not looking good, right? It's increasing. So what do we need to do? I think Kyle's saying it right there. We need to take that payment. We need to go here and drop in our payment right here and subtract the payment. So let's make sure we're going to let this do there and then put the payment on there. I'm going to redo these lines of code really quick. And even more so, we'll do that here in a second. Remember, don't just try to copy this all down. Try to understand what we're doing, because these are the steps. There you go. Now it's going down. Now it's going down. So when you look at this right here, once again, what have we created? What have we created here? What are we showing in theory and in practice right here? And then I'll talk about the last component of this. Boom, he's there. He's back. You know him, you love him. The skeleton's been found. But we have a problem with the while loop. The for loop uses the placeholder, such as like we could use I, which I often use, and put it through a vector, so that we can go here and print I. So object I not found, it's stored at the global environment now. But if you go here and go to a while loop, and you say while I is less than 100, I'm going to say less than 100, then run the function, and let's put I right here to 1, then run the function print I. What's about to happen? This is the last part of, or another component of what you need. What's about to happen right here? Well, then it's not going to run. But what's going to happen? So I haven't solved your condition. It's going to, great job, Jesse, right there. It's going to go. So how could we, because we could use some I's right here, right? But this doesn't change I. So how could I get I to move, which if you assign I's to this, you can do it. How can you get I to move? I'm talking the theory of what you need to solve right here. How can you get I to move? How can I change I inside my loop? Great job, Luciana, right there. We can go here and do I store into I plus 1. And now when we run the loop, it does basically the same as the for loop and does it right there. So does that make sense? Well, not after the loop. Yay! No, 500 points. Yeah, don't worry. That's, yeah. I plus 1. Just add 1 to it. And then as the loop runs, it just adds 1 to it. That's what it does. It's like, yeah. Just take the guesses. Don't worry. There's no penalty for being wrong here. You usually get more points if you're wrong. So, love to hear that. That's, oh, it makes my day when someone's like, I just guessed. You're like, yeah, that's right. You're like, first thought. Just give it a shot. Just type things. So with this right here, when you look at it, our condition, I'm giving some major hints right now. What should we be checking on the amount on our loan? No, you won't do I greater than 0. What should you be checking about the amount of your loan? What should you be checking? Here, I'm going to make an even more aggressive payment. And, whoops, not that. Because I should have stopped this loop. I should have stopped it, maybe even reported like, you will be refunded. Watch this. If I did it on the 4th thing right here, and I said cat, like, if, oh, sure, I could have done it on the 4th. If, no, cat, let's just do cat. Cat paste, there's what I want. Cat paste, because you get to put multiple things. You will be refunded, don't spell funded. Amount, gotta put comma. Amount, position $4. And we want negative that. Or times -1. Oh my gosh, -1 times that. And then we should what that. Someone fix up my message for me a little bit. We should what that. It doesn't look pretty right now. We're not going to get people output like that. Because I'm going to tell someone you'll be refunded that amount of dollars. Or your last payment had an overage of this. Or you'll be refunded this. Because you're like just sending them checks. Don't send checks. Round. Let's round it. So we can go right here and go round on this. And this is how we build code. So we know what it does. And then it says you'll be refunded. Does that make sense right there? So now we got something nice and pretty right here. Looking nice and good. Says what it'll do. So how would I check? What should I look at as I'm building this? I should always look at the what element. I should always, as I'm building this, I should always be looking at the what element on it. This is, I'm looking at it now. Are you looking at it? What should I be looking at it? The last. How could I find that? How can I find the last element every time this runs? How can I find that tail? And run the tail on amount. And what should I put as an argument? Close, Kyle, close. Good answers, Kyle. Tail, comma, 1. Great job right there, Luciana. You're getting it. And now, ooh. So we should see if the tail is what? We should see if the tail is what? I'm gonna write it. Let you figure it out. We should see if the tail is what? Because I don't think I should run that loop anymore, right? I don't think I should keep running the code. Because I'm just running the while loop right up there. We could see if it's negative, but then we would get a true if it's negative. Because if it's, we want loops to run while an argument is true. So, and technically not 0 or up, just greater than 0. We want to, because then if it's 0, we could stop because then we've paid it off. But if it's greater than 0, we want to keep paying. Yep. Does that make sense? And great work, everyone. Teamwork right there. If we do less than or equal to 0, that would say run the loop while you've paid it off. Does that make sense, Jesse, right there? If you do the last element is less than or equal to 0, that says if we've paid off the loan, run the loop. If we do the last element is greater than 0, it says if the loan is not paid off. Like if there's still an amount on the loan, like if the amount of loan is greater than 0, keep running your loop. If the last element, as we build this vector. So you've got a lot of components right here. These have been some major hints. You have to put it together and you have to explain it to people. You have to put these things together and explain it. You got a lot of, I basically gave you a bunch of, like, I gave you some filet, I gave you some portobello mushrooms, I gave you some béarnaise sauce, and I was like, you gotta put this on a plate and make it nice and fancy right here. Is this making sense? We did a little bit of help right here on how to do this and understanding it. And try to make some nice messages and stuff. Like, you can throw this inside of an if. So you want to think about how to make things nice and pretty right here. Your cat paste is really awesome because it'll do that right there for you. The only thing is don't get is the while loop the same function as the for loop. While loops run while a condition is true, and for loops run for a set amount of time. So for loop right here, how many times does this loop run right here? How many times did that loop run? Now, it didn't do anything, but how many times did it run? That's why it's called for. So it runs for a set amount of times. It ran 1,000 times. It didn't do anything. It just ran 1,000 times. It just went, just didn't do anything. Now, a while loop runs while a condition is true. So what's the problem here? It's going to run while that condition is true. So what's the problem? Uh-oh. What does this loop do? Oh, wait, no, we need it right here. Yeah, we can do that. Okay. Having some fun to end. Does anyone know what this loop does? So it says, create a start time right here, and then find the difference between the current system time and the start time, turn it into a number, and see if it's less than 2. So what's that loop do? That loop does what? And we might be able to show it even better if we run the code like this. Does anyone know what that loop does? This loop, I made a loop that is trying to do what? It's pretty interesting how fast it runs code sometimes. My loop runs basically while what? My loop runs while what? Because it's checking it at all points. So my loop runs while what? Watch this. We could go here, print Brian. It's comparing times, and it's seeing what? What's it seeing? My loop here will run for what? It's going to print Brian what? And so I'm putting that outside the loop to show you how much time has passed. Because my loop is set to run as long as a second hasn't passed. My loop will run for 1 second. This loop right here, it stores the current system time and then checks how much time is run. And this loop, great job right there, DD, good to see you here. This loop will run for 2 seconds. I mean, 10 seconds, 10 seconds. I don't know time anymore. This loop will run while less than 10 seconds have passed right here. So pretty interesting. You see it does it in about half of a hundredth of a second. or 0.05 of a second right there, but it'll run while the time differential is less than 10 seconds, and it'll just print Brian right there. So we don't want to write a condition like that for our calculation vector. We want to write a condition where we are checking the amounts and running while we haven't paid off a loan. My hair's just getting crazy. But what other questions are there? Didi, we need your coding knowledge. I know you have some coding knowledge right there. So we've got C++ coding knowledge here. We've got all different stuff. We got a lot of people are C++. So Shreya, Jesse, Kyle, what other questions are there? What are people thinking? We can do more 320, more 474. What are people thinking? Well, we did a lot of good work here today. So we did a function over here. We did some permutations. And earlier, way earlier, we did some graphics. Do we still have that up? There's fun. Look at all this coding done today. All the coding. What other questions are there? How would you print a graphic? So we don't really print the graphic. What we do is we just plot a graphic. We just go here and plot, and we can plot the amount. And so let's talk about that. Let's talk about making graphics real quick. Yeah, always awesome. Yep, and Treya, great work right there too. We're gonna throw some more points. Didi, you got to see what level you get to. And let's talk a little bit about making graphics again right here. So with making graphics, and we did this earlier today, so check it out, but we'll do a little more making graphics. ggplot, that's worth some 500 points. You know I love some ggplots right there. Yeah, I wouldn't make it inside the loop, because then you're going to make a... If you do it in a for loop, I mean, you could do it on the last iteration, but it's probably better to make it like outside your loop, because it's... You don't want to... You're not making a graphic for a certain amount of time, or making a graphic while something is true. You're just going to like run your loop, make a graphic. Does that make sense? Like run my loop, make a graphic of what I got. So if I were to take a loop right here, and if I were to say for, this is just a random thing right here. Nice stuff, Jesse. I'll show you two cool ways to plot stuff right here. For I in 1 through 200, let's store start value right here starts as 3000, and then let's subtract from 3000. Let's just say like what we do with our money or something like that. Let's store into start position I plus 1, because why am I storing into start position I plus 1? Because my vector that I'm going through is what? Why would I store into start position I plus 1? Because I want to store into position what to start. I'll write it. Why would I do that? Just think about what my loop does when it starts. So I want to start by doing what? I know I'm not making the skeleton first. I'm breaking the rules. Store into position 2. Skeletor, he's mad at me. Skeletor, I'm sorry. Okay, Skeletor. I'll write it. I'll do it. You win, Skeletor. We want to store into position 2. And from position 2, we will take what was in position 1, and we will add to it a random normal number. Back to Shreya's initial question. One more question. How do you know what to set the vector for the for loop for the loan? Can you reiterate the question, Parker? Reformat it. Let me know again. I'm trying to think. Random normal, one number, mean of 8, standard deviation of 10. So that's going to add a random number to it right here. And we want to take what was in position 1. Whoops. We want to take what was in position 1 right here. This is not your loop. Not your loop. Not the loop you're looking for right there. It's not the loop you're looking for. It's not. It's not. There we go. So this is just going to be like you have where you on average make about $8 a day that your banking increases, but there's a variation like a spread of 10. So sometimes you lose money, sometimes you make money, but on average you make more money than you decrease. So we're just going to look at what could happen here via randomness. And now we need to put in our placeholders where this becomes I plus 1 and this becomes I, which is what we had initially, to run it 200 times to see our vector. So we were making money over time, but if we want to look at it, we can quickly make it by going here and plotting it like this. There's our money generally increasing. But better yet, and thank you to Charles for mentioning this, we could go right here and we could make a data frame of it. Data frame, and I'll show you why I'm doing this here in a second. Let's call this money equals start, and then we put in here a second variable, which would be time equals 1 through length of start, which is how long it is. So this is our data frame right here of our money. And check it out. Chase, can you go over question 2 from the lab due tonight? Yeah, Chase, we'll probably end with that. And I think Parker's got one too, so we'll try to knock those out. I'm going to go here to a library called ggpubr, one of the best libraries there is. And we're going to do what's called gghist. No, ggline. There we go. And the ggline, I'm going to steal the code down here because I love taking code. No, we don't want that one. ggline. This is the right one, right? I think so. Ooh. Looks like you can do more, Shreya. I don't want those. Let's see. I think I want this. We don't need a y variable. Yep. Okay, we don't want a y variable of interest. Oh, we do. We do want time. Well, the y variable, our y variable is money, and our data frame is df, and our x is time. There we go. And now let's go here to geom theme, or gg theme. Theme. Let's go here. Pubr. Well, that's the same. Theme classic. All these different things we can do. And let's go here to color. Color equals hashtag, my brain's slowing down, FF8200. There we go. Nice and orange right there. Wade, I also have a quick question. What should I put in for the v equals to make sure the character vectors don't go through the loop? So you want to check to see if something is a character, and you could stop it. Is dot character of whatever you're entering in value. So if you want to check something, if it's a character, you can check this right here. And if it is a character, then you could break it. So think about the code you would run over here to end your loop. So is dot, not as DAWs, but is DAWs. Professor, you said y'all rewriting red class packages. We are trying to. That's one of the big goals right there, because there's so many nicer plots you can do. I might actually just do the labs right here. Do labs right here and do title equals my title. And now it's got a title. And do, well, we already got a y and an x. Like we could do y equals amount of money. And there you see it's changing it. Should be changing it. Why didn't it run? Oh, I did a capital Y. Look at that. Capitalization. That's how we get things wrong. And then time in bank. And there we go right there. So nice and easy. There's so many great things you can do with ggplots. Even better yet, another great library with this, ggeasy. We can go over here and add to the end of it, easy center plot. And that just centers it for you right there. And better yet, check this out. My favorite thing of all is you can go right here and go to library plotly and go ggplotly. And lo and behold, you have an interactive graphic where you can even zoom in on stuff. And you can actually put this on the web and everything. But ggplotly, Shreya knows right there, 100 points Shreya. Probably my favorite function of all. It just makes it instantaneous that when you take your object right there and turn it into a plotly object, it becomes totally interactive to where you could just take the scale and move it whatever you want. So you get an interactive like web graphic. So really cool right here. Now you can't knit these. You can't knit these. So watch out if you can try to knit. I know, right? That little of work, you just store your object into something and run it. Like technically speaking, you could take all of this. It just would be messy right there inside the ggplotly. Oh, because I grabbed that extra little thing right there. Preferably, I wouldn't do that. I like to take and store the object and then turn it into a plotly object. But also, if you have your object P right here, you can just take it and then pipe it through a theme and change the theme of it pretty quickly to, oh, is it unlike it? No. Really? We should be able to go, oh, you add themes. You don't pipe through a theme, you add a theme. Piping passes it through to the next thing, but you can change the theme of it pretty quickly to see different styles, which is really neat that you can just change between these themes right here for what you want. And we should be able to do the center title on this now. Easy center title. There you go. So not too bad. You can change the title of it. All this stuff right here and make a nice and neat plot. Pretty quick. Lots of options. And GG, the grammar of graphics. Shout out to Hadley Wickham. Really good stuff. We have a few more questions here. We'll try to knock those out. And great job, everybody. Glad to see people here. Next topic coming up is... we have question 2 on the lab. How do you find the value of payment that doesn't make the car loan decrease? Or, so then you'd have to see if amount 2 is greater than amount 1. So, Luciana right there, check if amount in position 2 is greater than position 1. Stop, break your loop. Break the loop and then report a message. Or just like, report a message, then break the loop. So if amount position 2 greater than amount position 1, run code, break loop, pat message, your loan was too high, or you didn't make enough payment. Does that make sense, Luciana? If amount position 2 greater than amount position 1, run code, break. Hopefully that helps out with that right there. So right here. Do you know what to set the vector for the for loop for the loan? Yes, you're setting it for the amount of time. Sorry, Parker, right there. You're setting it for the amount of time. And go over question 2 from the lab due tonight. Lab. Which was lab 2? Which was the question? Not parity. Cumulative sum, right? I saw a little cumulative sum function. Cumulative sum function. VA is 474. 474. Cumulative sum lab function. Let's check it out. The most important thing when you are writing functions. Oh, no worries, Chase. No worries, Chase. The most important thing when you're writing functions is to make it work on how many cases. The most important thing when writing functions is to make it work on how many cases. The most important thing when writing functions, just make it work once, right? So let's write a vector. You ready? Vector 1, 9, 10. Who here can tell me the cumulative sum of this vector? Cumulative sum means each element, just solve it, is an easier one to solve. So solve for me this cumulative sum right here. What the cumulative sum vector would be. And you can see what a cumulative sum vector is over there. Well, that's the cumulative sum of the full vector, but not the cumulative sum vector, which I think people were doing this. I think it's cumulative sum right there. That is the cumulative sum. Oh, I didn't store the vector. Oh, wait, what? Does it for you right there too. It's so I guess cumulative sum does it all anyways. We're doing things that we already have. 1, 10, 20. 1, 10, 20. No one was like cumulative sum in class today. Well, we're going to write the function for it. So for us to write the function, so, you know, hints, if you're working on this, a little hint right down on the screen. So if we're going to write this function, we have to think about what it's doing. So we want to be able to write these things and make our own functions. So how could we find the first element of the cumulative sum vector? Well, we could take our first element, and then what would we do with our first element? I know it sounds ridiculous, but we're doing a cumulative sum, so we should find the what of our first element. We're doing a cumulative sum, so we should find a what of our first element. We're doing a cumulative sum. The sum. There we go. How could I find the sum of elements 1 to 2? How could I find the sum of the elements 1 to 2? How could I do that? You got it. Great job, Charles, right there. And why don't we just make this one nice and pretty? Look at that. Those are the answers, right? How about we store these? Now, if you're going to store things, you might want to create a spot for them. How can I just create a blank vector? You don't have to call it a name yet. I'll go give it a name. I'll call it answer. So how could I create a blank vector inside? You got it. Blank vector. That just creates a blank spot for it. So where should I store this answer? Where should I store that answer? And it's the first answer. Where should I store that first answer? Position 1. Because if I do this, it'll just overwrite what's an answer. And we just get that. There we go. Looking good, right? Now, let's think about this. How long did I run that vector for? Or how long did I run this for? Why did I stop here? I mean, let's just keep going. Why don't I just keep going? Just, why not? That's weird. Why did I stop there? Why would I stop there? We just have 3 elements. So how could I figure out where to stop? Like, how could I figure out how long to run this loop for? I would keep running this loop while what? I could keep running this loop while what? I could do it with a for a while. I think I did both in the early class. Because your vector has what 3? It's the end of the vector, but it has what 3? You're right with 3, but use the terminology I know. It has what 3? It's the amount of values in the vector is 3 elements, and that's the what of the vector. 3 starts with an L, is the what of the vector. It's the amount of elements. That's very true. That's very true. How can we get it to tell me 3 with code, though? Is the length of the vector. Should we go for or a while on this? I'll go with the first answer someone says. I can do a for or a while on this. Either way is fine to work. It just had to be coded a little bit differently. A for or a while. Because I have to like code it differently depending if it's for or a while. I did both in the earlier class. A while. So the while is not going to allow me to manipulate the position. Jinx. So this is our skeleton right here. And we're going to store... And you see, what I want is to start I at 1. And then I want to then what I. Because I don't have the ability to manipulate I here. This is just going to keep running while I is less than or equal to the length of the vector. And so right now, I is less than or equal to the length of the vector. But so if I put this in here, what happens? So I'm trying to write it out so I can get it working and watch what happens if I run this. Because why? You can see it in my global environment right now. We're almost there. It's going to run while I is less than length of my vector. And right now I is 1 and vector length is 3. So it just keeps... Why? Hey, Elena, good to see you here. So what's the problem? And how do we fix it? Because it goes in here and it stores... We need the I plus 1, right? We need to increase I. We need to go I and I plus 1. So that'll increase I when the loop runs right there. And take a look. Answer. And we could do... You could go, if I equals length of vector, print answer. Does that work? No! Why is it? Oh, no. Okay. Yeah, because it... Yeah. Okay. Oh, no, I need to put it right here. Okay. We almost had it. There we go. There we go. Because it added I one more time. So I need to do it before I add I. So think about this. It only prints the vector when right here. So I added something that shows me the answer when I run this. Or because why? It only shows me the answer when I run this. Why? When does it show me the answer? If I is equal to the length of the vector, it prints the answer. So it only prints the answer when? As opposed to without the condition, it does that. It only prints the answer when. So I don't need this here. I'll leave it for a moment. It only prints the answer when it's on its last run, when it's finished. Because if I is the length of the vector, when it's not after. It's within the loop. So it's doing it within the loop right here. Like, I've only ran the loop. It only prints the answer inside the loop if I is equal to the length of the vector. And then when it adds to here, it goes back up to the start and the loop stops. So it only does it on the last iteration of the loop when I is equal to the length of the vector, like when it's gone through the length of the vector. I'm leaving this here for a reason, because when we do this right here, what we want to do is we want to turn this into a function. And the function, oops, I almost made a mistake. Fun right there. We're going to take our code right here, make it nice and pretty with Control-Shift-A. Nice and pretty code. And whoops, grab this, drop right here. And then inside of here, we'll put vector, which is the name of the variable we're manipulating. But I want to end the function world on line 72 and bring this thing back with me. On line 72, I have the answer. How can I bring that out of function world? What do I put around the answer to bring that out of function world? To bring that out of function world, what do I do? Return from function world with this. And there you go. Oh, it returned with it twice. Well, guess what? My little print of answer thing. You were beautiful, but now you're gone. You are beautiful, but now you're gone. There we go. Was not needed anymore. It was cool while it was in there, but it's gone. It's gone. Does that make sense right there? How are we doing? It could also be done with a for loop. For loop would have a little bit different of syntax. We don't need the I iterator for that. The for loop would go right here and say for I in 1 through the length of the vector you're using, run the following code, store into that. I might do it right there. And then let's drop it into cumulative sum. Cumulative sum, wait, run. And then go here. Good. Return from function world with my answer. Drop into cumulative sum. Call the vector. Run it, and we're good. So there's both ways to do it on the screen right there. I did the for loop one a little bit quickly. Using the while loop. Gotta be careful. Because I've already cleared my global environment, something tells me, why is the for loop breaking? Last question of the day right here. Why is the for loop mad? The while loop works, and the while loop runs, but the for loop does not run. Make sure you have a return on it, and make sure you've done it outside the loop. You might need to message me your code, but make sure you do it like where you haven't done it with a loop. So you want to get it working, that it works on its own, and then you want to put it inside of a function, and then you want to return with it. So the goal is not to write. You want to make sure you write down the steps, and I might have to see the code. But why is my for loop not working? What did I forget in the for loop? There's something on the while loop that is needed, and the answer's down here. Oops. There we go. We don't want that in the for loop. We want it to define before the for loop starts. And run. There we go. Well, we're gonna head off. I'm gonna check some Discord, get a few more glass of water. But with that, great job, everybody. Chase, message me on Discord. I've got some messages to go through. I've got 9+ messages as per usual. With that, great seeing everyone here today. Elena, good to see you. Shrey, good to see you. Chase, good to see you. Message me on Discord. I'll be checking out those messages. Bye for now, everyone. Bye. You're welcome, Shrey. You're welcome, Chase.